Hello everyone. We are moving on to page 102 in the Unit 2. We're going to talk about the getting ready. So instead of pushing this out to y'all and saying, hey, try something, I'm just going to walk you through these problems. And follow along with me. Treat this like notes, okay? On the first part here, it says write your answers on notebook paper. Show your work. Okay. Factor the expressions in items 1 through 4 completely. So whenever you see factor, factor means to rewrite something in terms of its factors. So we're going to factor 24, for example. We're going to factor it completely. Factoring is really referencing multiplication. Basically, what numbers can we multiply together to get 24? 2 times 12. So basically, we're making a factor tree. 24 is 2 times 12. But in order to factor it completely, I need to keep going. I can break down 12 into 2 times 6, and then 6 into 2 times 3. And I know I'm done when all the numbers at the end of the branches are prime, meaning they can only be broken down into itself times 1. 1 is not considered a useful factor. So the factors of 24, 2 times 2 times 2 times 3. And you can check yourself by multiplying all those factors back together, and you should get 24. 2 times 2 is 4, 2 times 3 is 6, and then 4 times 6 is 24. So then we would say the factors of 24 are 2, 2, 2, and 3. Okay? Now, common factors are not quite the same thing because I could have started with 4 and 6. Those are factors of 24. Also, I could have started with 3 times 8. Those are factors of 24. But to factor it completely, I need to break it down into its smallest possible parts. So again, 4, 6, 3, and 8, and 2 are all factors of 24. But to be completely factored, we would have to break it down into its smallest little parts. So right here, factor the expressions in item 1 through 4 completely. So number 1 here, your Khan Academy should help you with that. I'm going to factor 6x cubed y plus 12x squared y squared. So this plus sign means we have two separate terms here. We have the 6x cubed y and we have the 12x squared y squared. And we're looking for what they have in common. So the greatest common factor. What do both terms have in common? So in the Khan Academy videos, he says to start by first looking at the coefficients, the numbers in the front. What do 6 and 12? What is their greatest? What is the largest number that they have in common? Greatest equal largest. That number would be 6. 6 is the largest number that 6 and 12 have in common. Then we move on to the x's. I have x cubed and x squared. So x cubed there's 3 x's there. That's x times x times x. And x squared is just x times x. So what is the greatest they have in common? This one has 3 and this one has 2. What's the most they have in common? That would be 2. They both have 2 in common. So then x squared will be part of our GCF. So far we have 6 and we have x squared. Then we move on to the y's. We have y here and y squared here. Well, that's just one y, and y squared is y times y. So what's the most that they have in common? Well, this one only has 1, and that means they only have 1 in common. So 6x squared y is our greatest common factor for both terms. So that's the GCF. Now, after you factor that out, you're going to have leftovers. There's going to be something left over that they didn't have in common. So on this one, the number I didn't circle, the only thing I didn't circle was x. And then on this one, well, I factored out a 6, so that's 6 times 2. So I factored out the 6, so the leftover is a 2. And then the only other thing I didn't circle was the y. So it's 6x squared y times x plus 2y. And here's how we check this. Multiply it back together. Distribute. 6x squared y, 6 will come down. I'd add the exponents on the x's, and the y would come down. And then distribute. 6 times 2 is 12. X squared hangs on, and then y times y is y squared. And you should get back where you started. So basically, when you're factoring, you're multiplying in reverse. That's what factoring is. It's like division, sort of. Okay. Make some room here. Okay, on number 2, we have x squared plus 3x minus 40. This does not have a GCF. Okay, number 2, 3, and 4 do not have common factors, and I could tell by looking x squared, 3x, and negative 40. There's nothing they have in common. And I know these two have x's, but this one doesn't have an x, so we can't just factor out x. Now, if you remember multiplying problems like this, okay, they have the x plus the 3 and, I don't know, x plus 1. And we have to distribute. And then combine like terms. So we end up with x squared plus 4x plus 3. Okay? That's what this is. You're trying to figure out what two binomials were multiplied together to give you x squared plus 3x minus 40. So we're going to work backwards here and look for a pattern. So the 3 came from 3 times 1. And then the number in the middle, the 4, came from 1 plus 3. So we need two numbers that multiply to give us negative 40, but then add together to give us 3. So we need factors in negative 40. Negative 40 that add to give us 3, so that could be negative 10 times 4, but do those add up to 3? No, that'd be negative 7. How about negative 5 times 8? Negative 5 plus 8 does give us 3. So then our factors are going to have those numbers there. X minus 5 times x plus 8. And you can multiply them back together to check. Okay, on the third one, x squared minus 49. This one has a middle that's 0. You can imagine there's a 0x here. So you're looking for two numbers that multiply to give you 49, but add to give you 0. And those numbers are x minus 7 and x plus 7. Those are my favorite. And then finally, two numbers that multiply to give you 9 and add to give you negative 6. Well, those numbers are x minus 3 times x minus 3. So for this video, I want you to answer this question. Okay? Answer this. What does it mean to factor? Alright guys, I'm going to pause on this video and then I'm going to go on to do the rest of them in another video.